Okay, our next lesson involves solving equations that look a little bit different than what we've seen so far. We're solving equations with variables on both sides. That's what's different. So notice as we look at the examples here, I have letters on both sides of the equal sign. We have not seen that yet, where we have letters on both sides. So the new thing that we're learning to do today is we're learning how to move letters to one side, or variables to one side of the equation. Now, to compare this to what we saw in the last table, this is where the line, the equal sign is. So all of these moves from here to here involve doing the opposite operation, these three moves here. So this is our new one. We have undone addition or subtraction. We also call that clear the constant. We use the addition or subtraction property to do that. We undo multiplication or division. We've been calling that clear the coefficient. And today we're going to talk about how to check your answers, how to see if your answer makes sense. And we're going to use PEMDAS when we do that. Okay, or order of operations, another way to say that. All right, so let's look at this first one. Notice we have variables on both sides. So to get the variable alone, we first have to get the variables together. So we're going to start off right there. And the instructions up here said we're going to add or subtract term from both sides. All right, so here we have 6x's on this side and 8x's. We can't bring those together because there's an equal sign in the way. So to get them together, since they're on opposite sides, we have to do the opposite. So if I want to make this 8x disappear, for instance, I would subtract 8x. 8x minus 8x makes that disappear, and then I have to do it over here. So that's how we get our letters together. We make the letters on one side disappear, and then we repeat it over here. So 6x minus 8x, now I can combine them because they're on the same side, plus 3 equals, this is a good spot to forget to drop this negative down. That negative doesn't disappear. It is with that 21. So then, now it looks more like what we've seen before. We have two numbers over here with the letter, and the letter's all on one side. So we're going to take the negative 2x plus 3. There is a constant there. The constant in this problem would be the 3. And again, all these steps today are about opposite operations. I have a positive 3, so I'm going to subtract 3 to make it disappear. That leaves me with, again here, this is negative 21 minus 3. Some of you messing up your arithmetic there whenever you combine two negatives. In this manner, we're not multiplying, so we don't get a positive there. And then we're going to take the negative 2x equals negative 24 and clear the coefficient. So we're talking about the negative 2 here. To get rid of the multiplication, we've got to divide. So the negative 2 disappears, and we end up with x equals 12. Now, what we can do now is make sure that that answer is correct. So checking your answer is a good idea when we can do that. So here's how we do that. We're going to just write down the original problem, 6x plus 3 equals 8x minus 21 from the first box. We're going to plug in, wherever there's an x, we're going to plug in a 12. So it becomes 6 times 12 plus 3. And we're going to see if that's the same thing as 8 times 12 minus 21. So order of operations here says we've got to multiply first. So 6 times 12 is 72. and 72 plus 3 is 75. Now we got to make sure that that happens on this side. 8 times 12 is 96, and 96 minus 21 is 75. So that balances that equation, so I can say that 12 for sure is the solution. Okay. So now we're just going to practice these same steps again, this time with a different problem. Here, it doesn't matter which side you move the letter to or which side you clear, as long as you clear off one of the sides. So the left or the right side can be cleared. In this case, some things to remember. Remember, this is a negative 1x. When we have that negative sign and nothing behind it, just an x, then we have to think of that as a negative 1. So here, I could move these x's over to this side. So a lot of people here, because we have a negative, we're going to have to add in order to combine it with something that's on the opposite side. So right here, we've got 3x plus 2 equals negative 1x. I'm going to write it that way. Now, a lot of people like to get rid of the negatives, and to do that, to make negative 1x disappear, we would have to add 1x, and I have to do that over here under the x's that are on this side. So when I'm combining the like terms across the equal sign, I've got to do the opposite operation here. So on this side I have 4x's and a plus 2, and then negative 1x plus 1x is 0. So I have nothing left on that side. Now I'm going to clear the constant. Take the 4x plus 2 equals 0. The constant here is a plus 2, so I need to minus 2 to make the 2 disappear. Then I'm left with negative 2. Okay, so then we'll take that equation, and it does have a coefficient. In other words, it has multiplication there. So I'm going to have to divide to get rid of the 4. And in this case, that leaves me with x equals negative 0.5 if you divide, if you use the divide key. And that decimal's fine. It ends. It doesn't have to be rounded, so that decimal can be used. You could also know that that is the same thing as the fraction negative 1/2. So then we're going to check it. So we would write down the original problem here, which is 3x plus 2 equals, and this is another place that's very helpful to put in the negative 1 times x. Okay, so then I'm going to put in the negative 1/2 here and see if that works. So the negative 1/2 plus 2, and then I got to plug it in the other side. Everywhere there's an x. And you can use the decimal here. That's fine. The decimal is perfectly workable. It doesn't go on forever or repeat. So right here, this gets us with negative 1.5 plus 2. So that gives me a positive 1/2 on this side. Then this is negative 1/2 times negative 1. And that also gets me a positive 1/2 on that side. So that one checks, and I can be assured that negative 1/2 is the solution. Okay, then we do it again. And we've got the same situation, just different numbers. So I've got variables or letters on both sides. So here I've got negative 4x plus 2 equals negative 2x minus 6. Okay, so again here, I'm going to clear off one of these x terms. I'm on opposite sides, so when I have a negative 2x, I need to add 2x. Negative 2x plus 2x makes that a 0, makes it disappear. I've got to do it over here. So notice here, I have a negative I added, and that's what happened last time. I had a negative, so I added. And here, in the first one, I had a positive, so I subtracted. So the first two steps here involve addition or subtraction. Notice that. It's only the last step that we do division or sometimes multiplication. So this would leave us with negative 2x plus 2 equals, again, let's drop that negative down, don't forget about it. And then I see that I have a constant, this plus 2 right here. So to clear that, I've got to, again, do the opposite. I have a positive 2, so I need to minus 2 to make that disappear. Again, 2 negatives here, don't make a positive. 6 negative and 2 negative is negative 8. And I still have a coefficient, negative 2x equals negative 8. And I've got to divide on both sides to get rid of the multiplication that's here. That gets me a positive 4 answer. When I divide 2 negatives, I get a positive. And then we can check that. Negative 4x plus 2 equals negative 2x minus 6. So we're going to see if our 4 works here. So if you plug this in when you're doing this and you don't get these to work out, it could mean that you messed up your arithmetic when you checked, or it could mean that you made a mistake back in one of these boxes. So it gives you an opportunity to try to find your error. So I would multiply and then add. So this is negative 14 on this side. Over here, I have a multiplication of negative 8. When I subtract 6 from that, it also gives me negative 14, so it checks. All right. So now I want you to try 3 problems for me on the other side. So let's copy these down. These are the ones I want you to try to solve. We'll call them problem A. And I need you to solve 5x minus 3 equals 6 plus 2x. Again, and follow the procedures that are listed at the top up here. And then for problem B, I want you to try negative 6x plus 2 equals 3x minus 7. And for problem C, we'll have negative 2 plus 3x equals 7 plus 2x. Okay. So I want you to try these 3 problems on your own, and then we'll be checking them before we do another practice.